Hi there and welcome back to the second episode of our multithreading series. In our very first introductory episode, we have explored the basic terms like multithreading, concurrency, parallelism, etc. In case you missed that episode, I would recommend to check it once. You can find the link for the full playlist in this video description. And coming back to this episode, we will explore how concurrency works in Java with respect to CPU cores. So before we jump in, don't forget to hit that subscribe button. It makes me inspired to make more and more videos like this. Suppose we consider a CPU having a single core processor, and then there were two tasks which are held by thread 1 and thread 2 respectively, and these two threads were trying to access our available single core processor at the same time. So here the problem is, of course, both the threads cannot access our single core at the same time. And then the solution is one thread has to wait until another thread completes or it releases the CPU core for other thread, right? This mechanism of wait and execute the task through the threads is called thread scheduling. And this mechanism was handled by something called thread scheduler. So remember, even in our Java program, whenever we try to execute multiple tasks through the multiple threads, there is no guarantee for the order of execution, because there also this thread scheduler along with OS plays a vital role. I will demo the behavior of this thread scheduler in our next code example. And before that, if we also consider our modern systems, right, the CPUs are come with multiple processors, and there are n number of tasks need to be executed concurrently or at the same time, right? And believe me, this thread scheduling happens in such a fast way that these threads switch their context with respective cores in micro, nano or milliseconds. So in background, we will feel that multiple tasks are handled at the same time. Here you can see one of my personal system, that is MacBook Pro, how the CPU cores are there. There are totally 8 CPU cores. Out of that, 4 were used as performance cores for the high intensive tasks like compiling programs or rendering videos, and other 4 are known as efficiency cores, which are used for low CPU intensive tasks like email syncing, files downloading in the background. And coming back to Java, whenever we try to execute our program through JVM, by default JVM will create a one core thread known as main thread, and under this main thread all other worker threads were created to accomplish our task, also known as tail threads. Also, as we just discussed before, the execution order of these threads controlled by the thread scheduler and the operating system. So it's finally time to code in Java, what and all we discuss. Let's check how these threads behave with respect to our Java threads and CPU. So let's define a class named as thread core info demo. Next, I will write a statement to get the number of CPU cores using runtime class and will print it. Then in a simple for loop, we will create a 4 threads, and each thread will print its thread name and its ID, so that we'll come to know the thread name with respect to our thread number, right? And next, from each thread, I will try to call a method called heavy task, where we will put a simple loop which will iterate millions of times. It is just for heavy task purpose, that's it. And also putting that which thread ID executed this loop or this method. I'm just printing that also. Finally, whenever we execute this program, probably our expectation on this output is this one, right? In the output, threads were beginning from 1, but the thread names were 0. That is how the thread names were assigned. And the order of the execution is thread 1 holded by thread 0, thread 2 holded by thread 1, and so on. And then when computation is done, we might have think thread 1 executed first, then thread 2, thread 3, and thread 4. And similarly, they finish also in the same order. But this expectation may not be true always. In fact, 99% of the times it's go wrong, because that is how thread scheduler behaves. Let's check this actual output by executing our program. So this is my IntelliJ Java editor, and I have already written the program here. And the moment I run this and execute, here you go, you can see the output. If we try to compare our expected output with this actual output, there you can see there are a huge difference, right? The thread 2 was acquired by thread 1, thread 3 was acquired by thread 2. There is so much randomness here, right? Including the execution order. You can see thread 3 finished first, then thread 1 finished, then thread 2 finished, and finally thread 4. So if I try to execute this program again and again, every time you execute, you will receive a random output. That is how the thread scheduler behaves, okay? So to control this behavior, there are various methods or various measures we can take care in our Java thread-based program. But remember, we cannot fully control this behavior of the thread scheduler. We can only inform our JVM and thread scheduler the priority of our threads. That's it. In our upcoming episodes, we will explore more and more in depth about these threads and their behavior. So don't worry. And this is all about this episode. I hope now you're in a position to understand how the thread scheduler and threads behave. In our next episode, we will explore about thread lifecycle and various methods provided by the thread class to control its lifecycle. If you found this video helpful, please don't forget to like this video and also please share this with your friends. Happy coding and we'll see you in the next one.